Welcome to week 15, lesson 2. We are going to focus on substitution. Keep in mind that what we did last lesson was we graphed two equations to find where they crossed to find the solution. We're finding the same solution that we did in the last lesson, but we're just doing it with a different method. So first of all, let's figure out what substitution is. There's a picture of a basketball team here sitting on the side. What are they doing? They're getting ready to be substituted into the game. Well, how does that work? They get put in and somebody else gets taken out. Or in this case, 5 people get put in and 5 other people come out. So you're replacing something with something else. You've seen this in math with a very basic equation here. We can solve this and get x equals 3. I can substitute 3 back in for x to check the solution. Okay, so the idea of substitution is replacing something with something else of equal value. Hopefully you recognize these equations. This is from the introduction, same equations. I'm showing you, you should already know that the answer to this is 5540 from the intro and from lesson 1. I'm going to show you how to do this using substitution. So there's 4 steps typically, not always, but typically there's 4 steps. Step 1, solve for one variable. What does that mean? It means isolate one of the variables. I'm going to take the first equation here, and I could isolate x or y. It doesn't really matter which one. So I'm just going to subtract y to show you that it doesn't matter. So I get x equals 95 minus y. So 95 minus y has the same value as just a single x. So what I'm going to do is I'm going to make a substitution using the other equation. So in this case, it's the second equation, but it's always the other equation. So I'm going to rewrite that equation. 8x plus 5y equals 640. But I know that x equals 95 minus y. Can I use that to help me? Sure. Let me show you. 8, and I'm going to take x out and replace it with something that means the same thing as x, or 95 minus y. Plus 5y, you got to continue writing the equation, equals 640. So basically, these two equations in step 2 are the same because I know that x equals 95 minus y. Why is this a nicer equation here? Because it's got one variable. Yes, I know you might be looking at it and say, no, there's 2 there, but they're the same variable. I can solve that. Distribute the 8. You get 8 times 95 is 760. 8 times negative y is negative 8y. Plus 5y equals 640. Combine my y's to make negative 3y. Subtract the 760 from both sides. Divide by negative 3. And you get y equals 40. So step 2 is kind of where a lot of your work comes in. Step 3 is use the other equations, the first equation, substitute in the value you just got. So I'm going to put 40 back into equation 1. X plus y equals 95. I'm putting 40 in for y. I can solve now for x and get x equals 55. Step 4 is write the solution as a point. So it's the point 55, 40. Check your answer. Just like we did with graphing, let's check our answer here. 55 plus 40 is 95. 95 equals 95. 8 times 55 plus 5 times 40. That does equal 640, which is what we expected. Okay. A little reminder here for systems, just systems in general. We talked about this at the end of lesson 1. You could have one solution, no solutions, or infinitely many solutions. We know what each of these looks like graphically. What do they look like algebraically? Okay, so a reminder, one solution is if they intersect, slopes are different. No solutions if they're parallel, so the slopes are the same, but the y-intercepts are different. And infinite solutions are the lines are the same, so same slope and same y-intercept. What about if we have a system like this? Well, we got to get a variable by itself. So I'm going to take the first equation. Doesn't have to be the first one, but I'm going to take it because it's got this y right here that has a 1 in front of it. That 1 is much easier to solve for. All I have to do is add 2x to both sides. And when I do, I have negative 1 plus 2x equal to y. Now I can take that and plug it into the second equation. So I'm going to take negative 1 plus 2x. It doesn't go in for x this time. It goes in for y. So I'm going to rewrite this equation, negative 4x plus 2, taking y out and replacing it with negative 1 plus 2x. Distribute. 2 times negative 1 is negative 2. 2 times 2x is 4x. Put my x's together. Negative 4x plus 4x cancels, right? The x's are gone. It makes 0 x's. And I'm left with -2 equals -2. If the variables cancel like they did here, and the remaining numbers are equal, you have infinitely many solutions. These are the same lines. If I would solve these both for y, they would be the exact same. In these situations, there's no step 3 and step 4. I don't have to check anything. Infinitely many solutions is my answer. Last example for today's lesson. Y equals x plus 1. You got -x plus y equals -1. I already actually have a variable by itself. The first equation has y by itself. So I can jump straight to step 2. I'm going to replace y with x plus 1. Add the things together. -x plus x is 0x. They cancel. 1 does not equal -1. If the variables cancel and the remaining numbers are not equal, you have no solutions. And again, you can skip steps 3 and 4. So that's substitution, and that concludes lesson 2.